Daddy, how do I become successful?
Here, son, you become successful by finding the arc length of the curve. All right, let's just start. The first formula will be t squared 2 over 3 t to the power of 3. And you're trying to find the curve from t0 to t1. So, what's the arc length of the curve? It's literally just the length of the curve. It's the length of the space curve from point 0 in time to 1. So maybe you have a little spinning motion. Maybe you have like a little spinning motion right here. Like I don't think I can draw it that well. Here, let me. Yeah, I'm not even gonna try. Imagine you have a spiral and you see a point on that spiral. Fuck, I'm just gonna get into the video. I don't care. So I'll show you the formula. So formula A, integral of A to B of the magnitude of r theta t d of t. So what's the r here? R is the function of the space curve. R is literally just the function of the space curve. Let's write that with red. R of t is up here. So what's the derivative of position? Velocity. So basically we can solve this problem step by step. And I'll show you this with this equation here. R prime, so the derivative of position, is equal to velocity. And all we have to do is find the derivative of this vector value function. So what's a derivative? Well, derivative of t is just 1. Derivative of 2t, t to the power of 2, sorry, is 2t. And a derivative of 2 to the power of 3, 2 over 3 times t to the power of 3. Yeah. Equals, what is that? 2t squared. So, what do you do here? Well, the next part is finding the magnitude of r of t. How do you find the magnitude? You just square all, so how do you find the magnitude? You square all the components of a vector. So if you wanted to find the magnitude of this vector, what would you do? Well, you find the square root of the sum of all the squares of the components inside the vector. So 1 to the power of 2, 2 to the power of 2, 3 to the power of 2 here. So what do you do with this function? Well, you can find the magnitude of it by just squaring all the components inside of here. You find the square root of 1 squared plus 2t squared plus 2t squared. Oh, I wrote that wrong. Oops. 2t squared plus 2t squared squared. So as you can see, I just squared all the components inside of this vector value function, and you get the magnitude. Once you do that, all you have to do is put it into an integral. Now here's the thing of this. Well, the bounds a and b, forgot to say this, the bounds a and b here are just the bounds you're integrating upon, or the bound you're trying to find the length upon. So if you have a space curve, you're not going to find the length of the infinite space curve. The length is just going to be infinite. Okay, you're going to find it within a certain range of t. So from 0 to 1, that's the bounds. From the lowest one to the highest one, 0 to 1. Now we put this into an integral, but typically, after you do this part, the hardest part is done. Actually, no. The hardest part is to come, because the rest of this is algebraic manipulation. Boo-hoo, boo-hoo. Okay, I know. Just a lot of algebra. I'm not going to lie. You're going to use algebra for the rest of your life. But let's take this down somewhere here. What you can actually notice from this is, well, 1 squared. Let's remove this squared here. But 1 squared is just 1. So what do we get? We get 1 plus 4t squared plus 4t to the power of 4. What does this turn into? Oh, looky here. You can actually square root this to get this. These two are equal. So what does this integral turn into? 0 to 1, the square root of 2t squared plus 1 all squared. Isn't that neat? So once you have this, this root actually cancels out with the square here. So you get an integral of 0 to 1 of 2t squared plus 1 d of t. And the rest is just up to you. But I'm going to move on to the next problem because hopefully you could do a calculus 1 problem by now. I mean, like, this is a calculus 1 problem, so I'll move on. Okay, this next problem is going to be what is it? So cosine of t, sine of t, and t. And our bounds are 0, t to 2 pi. And I'll just clarify this is r of t. So what was our formula? I'll write this down here. A to b of the magnitude of r prime. So I'd recommend that you try this out first by yourself. Set up the problem. But mostly, this is just calculus 1 with algebra and vectors. That's the only difference. Now that you've done it, hopefully, I'm going to show you how to do this. So, r prime. You just find the derivative of every single component inside of this vector. What's the derivative of cosine of t? Negative sine of t. What's the derivative of sine? Cosine of t. What's the derivative of 1? Derivative of t, 1. Alright. We have r prime. Now we have to find the magnitude of r prime. The magnitude of r prime is sine of t. Since this negative cancels out when you square t, when you square sine, it doesn't matter what value sine is. If sine is negative, the negative cancels out. So I'm just going to square sine here. Same for cosine of t, plus 1 squared. Now, trig identity here. This right here is equal to 1. Sine squared of t plus cosine squared of t is equal to 1. Or you can use x. I'll use x, traditional x. But when you have two of the same variables, you square both of them. Equals to 1 for sine squared and cosine squared. So we can actually turn this to 1. Yippee. That's easy. Oh, wait. Oh, fuck. Hold up. Let me go back. There you go. So we have 1 plus 1 here, actually. And this just equals to square root of 2. Once we get square root of 2, all you have to do is plug in square root of 2 into this integral. And let's set that up here. So the bounds are 2 pi, right? 0 to 2 pi. So square root of 2 is our magnitude of r prime. And this is with respect to t. So this right here turns into, redid that, square root of 2 times t integrated upon the bounds of 2 pi and 0. And if you do that, you get 2 pi square root of 2. That was the answer, by the way, 2 pi square root of 2. If you couldn't get that. Alright, number 3, 5 cosine of t, 5 sine of t, and 2t. Alright. Let's get this. This problem is very, very similar to the previous one, actually. Yeah. Because maybe you already see it. Yeah, I have to stop erasing this fucking formula, bro. That shit's so annoying to write down every time. Okay. R prime. So, we integrate everything here. Integrate it? Derive it. Derive everything here. Derivative of cosine t is negative 5 sine of t. And derivative of 5 sine of t, negative, is 5 cosine t. Derivative of 2t is 2. All right, find the magnitude of this. So we're going to square all the components of this vector and square root everything. You end up with 25 sine squared of t plus 25 cosine squared of t plus 4. And I got the 4 from 2 squared. So, once you figure this out, oh, this one's a little harder. Okay, I'll figure this out along with you guys. Let's do some algebraic manipulation. Let's factor out a 25 out of everything here. If you factor out 25 out of everything, you get sine squared of t plus 25. Nope, not 25. Plus cosine squared of t plus 4 over 25. And this 5 turns into a 5 out here. The root of 1 plus, because sine squared and cosine. Yeah, I'm going to remove the square root. 1 plus 425. This right here, again, turns into a 1. And I just factored out the 25 to get 5 on the outside of this equation. Once you get this, I don't know, maybe I'll do a little more. 5, make this look neater. What is this, 29 over 25. And then, this is easy. You get 5 square root of 29 over 5. Then these cancel out. What do you get? Your final product all the way at the bottom here is square root of 29. I'm not going to use orange for that. So square root of 29 is our magnitude of our t. RT prime. Yeah. What bounds are we integrating upon? Yep. Didn't write that down. Great. At least I'm just working through this. The bounds are 0 and 4 pi. So 0 and 4 pi is what we're integrating upon. Square root of 29 is the magnitude of the derivative of r. Integrating with respect to t. So all you get here is square root of 29t, 0. It's going out of the screen probably. There you go. Let's fix the 4. 4 pi. And what do you get here? Square root of Let's write the integers first. The non-radicals first. That's our answer. Yeah, I don't know why I didn't do the first one. I guess these ones are easier to do, so I'm just gonna do them for you guys as well. Make sure you get the right answer. Okay, last problem. Great. Great, I totally didn't cut out a previous problem. Yeah, I don't know. You guys will not see that, but I had this, like, you know, I'm not gonna lie, I use ChatGPT to give me practice problems for these videos, and I don't solve them beforehand. So I'm just solving along with you guys. And, like, I was solving the last one, and I was like, that shit's way too tedious. Like, I have to square, like, I have to use FOIL. Yeah, fuck that! So let's do this one. Alright, this is a new problem. This is a new, better problem. And our bounds are 0, TLN 3. I told myself I wouldn't erase this fucking formula, but I'm still doing it. Brain farting. Where do I start? Okay, yep. Start with finding a derivative. So you find the derivative, r, here. Just the derivative of all the components inside of this vector value function. Derivative of e power of t, which is e to the power of t. Derivative of e to the power of negative t is negative e to the power of negative t because chain rule, and derivative of a constant with a single powered variable is just the constant or the coefficient. So on the magnitude now. So the magnitude is e to the power of t squared, so it's e to the power of 2t. If you didn't know that, if you square anything, it's basically like multiplying it, right? And if you multiply two functions with the same bases, it's just like adding them. Multiply two exponents with the same basis, it's just like adding them. And if you add t and t, you get e to the power of 2t. Let's go ahead and do that. But let's put negative e to the power of t squared. The negative actually cancels out because you squared it, but the negative at the top does not cancel out. So you get e to the power of negative 2t. And you just get 2 here. Oh, what do we do here? Oh, what do we do here? Yeah, you will not know how to solve this unless if you fucking just know it. I need to stop swearing if you just know it. I'm going to show you how to do this. But this one's a little annoying. I'm not going to lie. But maybe you're like good at algebra and you can see this already. But this is the equivalent of that. Why? Well, you can use FOIL on this because we're squaring this function here. If you end up using FOIL, let's use FOIL actually, you get e to the power of 2t. So you actually get, oh, what did I undo? I'll redo it. I undo the 2 right up there. But let me show you how this works. If you square anything, you just multiply it by itself again. And if you use FOIL here, you get e to the power of 2t because these two are multiplied. And then you get plus e to the power of t times e to the power of negative t. And when you multiply things, as I said before, what happens? This turns into e to the power of t minus t, which is equal to e to the power of 0, which is equal to 1. If you just keep using FOIL, alright, e to the power of negative t again, times e to the power of t. Same thing happens. Same thing happens. I don't even need to draw the equations again. And then e to the power of negative t times e to the power of negative t, blah, 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 blah. You get this. And all of this simplified turns into e to the power of 2t plus e to the power of negative 2t plus 2. 1 plus 1. So these two are 1s here. And what's this? This, same thing as that. So, yeah, if you didn't know that, then you would be cooked on this problem. But now that you know that, great, you're not cooked. Let's keep going. Alright. This simplifies. The root cancels out with the square. So this simplifies to e to the power of t plus e to the power of negative t. After that, just integrate along the boundary. 0 ln 3 of e to the power of t because we're substituting magnitude of r prime with what we found with algebraic simplification. And we continue. There you go. This is our integral. I'll just fully solve it. E to the power of t minus e to the power of negative t along the bounds of ln 3. So what happens, we get e to the power of t. We get e to the power of ln, actually. ln minus e to the power of negative ln 3 minus, we have to put in parentheses, e to the power of 0 minus e to the power of 0. So just 1 minus 1, this cancels out, turns into 0. So all that we're left with is e to the power of ln 3 minus e to the power of negative ln 3. What pre-calculus probably taught you is ln's base is e, so if you do e to the power of ln 3, you get 3. And then, what is this? It's 1/3. I mean, like, once you get this answer, you can stop there. Honestly, once you get this answer, you can just stop. It's still a constant, it's an answer, but I'll just simplify it for you guys. This is 8 to the power of 3. I don't know, how did I get this? Oh, some of you may be asking, how did I get negative, shit. How did I get 1/3 from e to the power of negative ln 3? Another trig identity. Not trig identity. I'm saying that word a little too much. Pre-calculus identity. This right here is equal to ln of 1/3. Also known as ln of 3 to the power of negative 1. And then if you have ln of 1/3, e to the power of ln 1/3 is just 1/3. I'll explain that in my pre-calculus videos when I make them. So, that was it for today's video. If you have any questions, put it down in the comment sections. Hope you guys learned something.